we're going to use an analogy to see what happens when the amounts of reactants are not there in the stoichiometric ratio. So let's just look at tomato sandwiches, and I'm going to keep it really simple and say that we need 2 pieces of bread and 1 tomato, I guess this is a slice of tomato, to make 1 sandwich. And so we could think of these as our coefficients. I need 2 pieces of bread, 1 tomato, and if I have that, I can get 1 sandwich. Okay, well, what if I have 4 pieces of bread and 2 tomatoes? Well, I would have twice as much. I've kind of doubled my recipe. It looks like I could have 2 sandwiches. What if I have 6 pieces of bread and 3 tomatoes? Well, that's pretty easy. I could get 3 sandwiches. And here's the tricky one. Well, what if I have 6 pieces of bread and only 2 tomatoes? How many sandwiches could I make? And the answer is that I could only get 2. And that's because I don't have enough tomatoes, right? So let's kind of focus on that one. So if you think about how we decided that we would only get 2 sandwiches, is that we kind of just quickly looked and said, well, it looks like I don't have enough tomatoes, and so I'm limited to 2 sandwiches since I only have 2 tomatoes. We would call this the limiting reagent. And since I have extra bread, I'm going to call that the excess reagent. Okay, a few things to point out about this. So this is the amount we're going to get. This is what we call the theoretical yield. Okay, a few things to point out about this. You know, these were pretty simple numbers, so it's pretty easy to tell what our theoretical yield would be and to see that we're not going to have enough tomatoes. But if it's more complicated in its chemistry and stuff, the way that we do this for chemical reactions is we'll look at each reactant and see how much product it could produce. In other words, I could look at 6 pieces of bread and say, okay, I would get 3 sandwiches. And I could look at 2 tomatoes. That would give me 2. And then I would compare these 2 numbers and say which one is lower, and that's going to be my theoretical yield. So we'll go through those steps with some chemical reactions. Another thing is, notice that when the reaction takes place and you make the sandwiches, the limiting reagent does determine the amount that you get because it runs out. But there's going to be some excess reagent left over. So in other words, in this reaction here, we get 2 sandwiches, but we still have 2 pieces of bread left over. So that happens in chemistry too. When you put together reactants in the ratios that aren't exactly like the equation, one will run out and it will determine how much product you get, and the other one won't all react and it'll still be there, kind of like our extra 2 pieces of bread. We're going to look at a really simple chemical reaction. This is the reaction used to make aspirin, and I've used words and abbreviations here. This is salicylic acid and acetic anhydride, and I'm just going to call them SA and AA to kind of make it easier to keep track of what's going on. So let's just say that I put together in the lab, I put together 1 mole of SA, salicylic acid, and 2 moles of AA. Now I didn't show you, these coefficients are all 1. Okay, so an equation where they're all a 1-to-1 ratio. Okay, and so this is what I was talking about, how we decide when we're doing chemistry, which is in excess and what is our theoretical yield and so forth. What we do is we look at each one and decide how much product you could get. So I'm going to start by looking at the salicylic acid, there's 1 mole. If all of that reacted, I would get 1 mole of aspirin. Okay, and then I'm going to ignore salicylic acid and look at acetic anhydride. There are 2 moles of AA, and if all of that reacted, I would get 2 moles of aspirin. Okay, and then I compare those 2 numbers, and the lower one is the theoretical yield. So I always cross out the one that over predicted how much product, and the theoretical yield is the 1 mole, the lower amount predicted. Okay, so that means the one that predicts the lower amount is my limiting reagent. And we sometimes abbreviate that. And the one that over predicted product we call our excess reagent. Okay, and that's how I was saying we will predict those, is we'll look at how much yield based on each of the reactants, choose the one that predicts the lesser amount of product, and that is the true amount of product, and that reactant is the limiting reagent. So here are some definitions. I want you to note that the word reagent means reactant. And so a limiting reagent will always be one of the reactants that is there before the arrow. But sometimes that's confusing because we determine which one is limiting based on how much product there is, but it's always referring to a reactant. Okay, because all of the limiting reagent reacts and some of the excess is just there and has nothing to do with the amount of product that's there, just like extra bread doesn't give you more sandwiches, all of your calculations have to be based on the limiting reagent. Kind of like with our predicting how many sandwiches we could get. We looked at how many tomatoes we had because they ran out.